Yeah. Using it as often as be nice. Hmm. Get ready to get the domain and range. Discuss with your neighbor, make sure they got it too. I'll be right back. I'll grab some more. Nice.
That was like
The problem.
he's not.
Then to get the range, you have to find vertex.
Oh my God.
So that's when you do the vertex name, so that's you.
We mean from house.
Yes, it's.
Why did I say home? What's my favorite cookies ever?
Really? You want one? The range. No, because you told me the.
There's the. Yeah,
My favorite cookie.
There's directory stuff.
What's my favorite ever? And there's.
There's, can you please bless me?
You can share this with me.
Eugene?
James.
Get a full.
You don't get one now.
No.
That's not my fault.
There's, you have, no, there's, you have to give them a full.
Oh, no.
I'll split one
Wait, we're
with
getting
you.
the birthday.
Oh,
Brad. I like this. Okay.
Oh my God.
man, those are hella good.
You're not.
What? Upsets explode. That's not what it says.
And then when we ask.
Man.
By the way, I'm.
Give us assumptions.
Yeah. I think it's like mine was like. So you just made this on myself last.
Yeah, well, the domain is like, but the range, right, you have to find the vertex because the range is up and down. So then we have to find the vertex and find the. I was gonna say, yeah, but it's negative. Um, Wait, what did you get for the X? Your position too, yeah. See. I just, it's on, I'll just come. So you got. One, we have one. Jackie, have one?
Yeah.
Here. When it, that's not minus five, so then it's negative.
Well, you have one too. You had to say, mine was different.
0.6 because two A, so then A is.
I think now, the egg and piece of salad.
Even me.
Yeah. What'd you get?
Now.
March 3rd.
Why?
Exclamation.
What six?
Ethan. What'd you get for the range?
I get to do.
2.65. Or should I go? I got negative.
Yeah, use a response.
God, have you source?
I mean, really, like. 0.3 times 9.
6. You divided.
I just know shit. Like, you can just ask me, that's small place now we know. 3 times 9, 27.
Interesting.
1.3 times 9.
So then-
27.
Okay, finish that later. I know it's 6, right? Okay, so you've had plenty of time to work on this. Let's see what you got. I just wanted the domain and range. We'll work on the calculators in a little bit. You're not supposed to be doing the warm up to this. What happened to the projection? It's a little awkward. What's happening here? The projector is not projecting, huh? Oh, there we go. Something. Okay. Thank you for your patience. Just go ahead and have a seat in your chair. And if I just gave you a calculator, please make sure you give it back to me today. I stole these from other teachers and I'll be very mad if they know about that. So can't Upton can't help me today, but hopefully James, can you help me with the domain and range? Okay, I'm just a mess today. I have no idea what I do with my stylus. Where did I put it? It's so awkward. Okay. I'm sorry, can you tell me the domain again? Okay. Negative 189, like that?
Positive 189.
Positive 189? Okay. Positive 189. Bracket, you're saying. And where'd that 189 come from? No, I'd like to know where you got the 189. Where did 80 come from? Okay, so it's important to find the vertex of this. In order to do that, you need the x value so that you can find the y value, and the x value is negative b over 2a. James, thank you for reminding us of that. Make sure it's in your head. It's great to work with a partner, but also got to be in your head. And we know that it starts at negative infinity and goes to that point because its parabola is yeah, the leading coefficient is negative. It's opening down, so from floor to ceiling, negative infinity to that y value of the vertex. So, and of course, that 189 would be called the what of the function?
Maximum.
The maximum of the function. And that happens at x equals, it's 80. Is it exactly 80? Okay, cool. So one of the reasons that math is around is so that we could actually use it to model things in the real world. So one thing that's modeled quite often is, or one thing that we use is quadratics. So today, parabola specifically, and like when the guest teacher was here, it's physically done, like a shape of a, what was it?
A satellite ring.
Satellite dish. It's called a paraboloid. Paraboloid because it's parabola in each direction, which is kind of interesting. So there was that, and there was also in headlights. She was talking about so the headlights are shining forwards instead of just like wherever. Where else? Rainbows. I think rainbow is more of a circle. Yeah, it's a perfect circle actually. Has anyone seen a full rainbow circle? Where did you see that? What's that? In the sky? Like, did anyone see the full circle? The full circle of a rainbow? Normally we just see the top. It was? Interesting.
It's like a few years ago, I remember it.
I haven't seen it. Where else would you see something like that? Has anyone seen something like that? A full rainbow, like a full circle?
I see it when I'm like
What's that?
watering the grass.
It's like it's time.
Number 50. What's up?
I think if you're standing like at the rim of the Grand Canyon or something like that, then it won't stop, right? It'll keep going. You were in LA. I think that there are other phenomena where you would see a circle like around the moon or something like that.
Low circle. Brother. What?
Yeah, maybe up from very high or some buildings. I don't know. In any case, let's the other one is just the path of a flying object. And that's actually normally where we're see it, right? It follows a parabola. Okay, so let's do it. Oh, here it is. It's right on my desk. Okay.
What do you want?
So we're on day 3 of the packet. And this figure shows that when the football is kicked, the nearest defensive player is 6 feet from the point of impact of the kicker's foot. The height of the punted ball, f of x, will be modeled by that function. Okay, where y is the ball's horizontal distance in feet from the point of impact with the kicker's foot. What do you think that 2 there represents? Oh yeah, James.
No, about the football from.
Oh.
How many units are there?
I may ask that later because I'm kind of in a flow right now. But hold on to that question. It's an important one. So James, you said that 2 represents the. Not James, Joseph. Joseph, you said that it represents the y-intercept. And with respect to this problem, that 2 represents where the ball is kicked from. So it's not from the ground, it's 2 feet above. And you can see that kind of in the diagram. And if we were to follow this, it wouldn't be a line, it would be something like, it would be a parabola. And I don't know if that parabola is opening down because it's gravity. That balls are not going to go up to the moon. Maybe if you kick it, if Luke kicks it with his mathematical skills, maybe. But also we could just see the function. The leading coefficient is negative. So we know it's definitely modeling appropriately. This thing is coming back down to Earth, as it should. Okay, so graph the function that models the football's parabolic path. Okay, I'm going to do a really, let's do a good graph. What would be important to find here?
How high? Like,
How high? Yeah, we need to figure out the maxes. In other words, the what of the route of the vertex. So let's do that. And you can use your calculator to get these values since you have them. I'm going to call on someone to give me the vertex. Make sure your neighbor got the same thing you did. And make sure to check in with your neighbor.
I got 0.0059, but that doesn't sound right. What'd you get?
I'm still trying, but I can't even.
I got 59.
Why am I getting?
I mean, like, I have my.
Why am I getting? Yeah, is that what you got? Yeah.
Yeah, right now you're not graphing anything, folks. Not on your calculator, just get the x value of the vertex.
Oh, man.
So right now I'm looking for is a x equals negative b over 2a. So you just plug these things in and crunch the numbers. Did he get it? Joseph, do you have the X value of the
The X value 59.
59? Do we agree?
I did not.
Yeah.
59? Someone else got, Luke, you got 59? Okay, so Luke verified. Okay, and a double Ethan verified, okay.
I got 0.005.
You have to, punch in your calculator the denominator first, and then divide the numerator. So just putting a fraction.
Oh,
Decided to put it in fraction.
yeah. Yeah, make sure you can get that 50, and is it exactly 59?
You
Okay,
have to plug it into the X.
right, well, I'm just looking for the vertex, so we have that 59. And now we do have to plug that in so we could get the
You have to
height. So Joseph, thank you for the X value. Tess, did you get the Y value? What's that? Luke? Okay, so Luke verified. 36.81. Ethan? Okay. Raquel is Raquel verified? Okay, cool. So that is the vertex here. So let's start graphing this based on just this information. I'm gonna start here at 2. That's 1 point. The next point I'm gonna write is 59, comma 36.81. And is it going up to space? Now, James is not involved with this problem. It's coming back down. So would you please discuss with your neighbor one more point on this graph? One more easy point to get on this graph. Okay, so who'd like to tell us the other easy point? Yes, Inaris.
Well, I guess it's not. I said axis of symmetry, but I guess it's not really.
No.
That's what I'm thinking. I'm thinking about was anyone else considering this when they got their other point? I'm looking for this.
Okay.
Why wouldn't you do
Wait, why
the
wouldn't
X,
you-
the X intercept? Because you don't want the axis of symmetry.
I wanna-
Because you want to know when it's the ground, not when it's possible.
I'm just trying to find an easy point. Like a specific easy point. So Inaris, you want to follow the train of thought?
Yeah, so we could get where it hits the x-axis.
We could, but I think that before that, we're gonna find the really easy point. You said what I'm talking about? Which one? What is it?
Like right next to it, like.
Yeah,
line of symmetry.
right. So what's that? What's the X value for that?
So
Well, would you check with your neighbor? What is the X value of the point that we're looking at?
16. B.
It is 118, isn't it? So if the ball is following this parabola,
so 9 plus 9 is 18.
what this is saying is that after 59 feet of horizontal distance, it's reached the height of
22.
33 feet. So if you would have gotten something like 3,000, find your error, or if you got something like 0.2, find your error, right?
Down.
Right? Well, then it's like, what?
Yeah, weird spin on it, like.
Maybe some trick. Yeah,
Then-
I don't know. Okay, so 59 feet horizontally, it's reached the height of 30 feet, 36.81. So after 118 feet of horizontal distance, it's now at how high? 2 feet high, isn't it? That's the symmetry. Which means we know that it's going to hit the ground. It's about to hit that. It's about to hit it, right? Just a little bit past 118. But this is I hope you agree when I say this is the easy. These are the easy points to get.
Yeah.
Once you understand how to put these things together, but we know the vertex, we know that y-intercept. So we know it's going to do something like this. So this is all I want to draw. So I don't need like 5 points. Should I go down below the x-axis? Only if there's a strange hole in the field that it just continues to fall through. I think it's just probably just going to bounce right there. And that's when we stop caring about the trajectory of the ball. Okay, so B, I think we already answered this, didn't we? What's the maximum height of the punt and how far from the point of impact does this occur? Height is 36.81 feet, which happens at 59 feet from the kicker. Or the point of impact or something like that. Yes? I hope it makes perfect sense. How far to the nearest defensive player who is 6 feet from the kicker's point of impact? Wait, how far must the nearest defensive player who is 6 feet from the kicker's point of impact reach to block the punt? Okay, so here he is. There's the guy. He's 6 feet from the punt. Now, how far does he have to reach? Now, how far does he have to jump? How far does he have to
8 feet.
reach? Just reach. So they could be 1 foot tall. They could be 8 feet tall. Because how far do they have to be able to reach?
8 feet.
It's 8 feet. How do we know this?
You look at the graph.
Looking at the graph. But I don't know if that's an accurate graph. It does appear to be about 8 feet. How can we figure out exactly? Yeah, Ethan? Does that make sense? Find f of 6. I like that idea. Yeah, that will give us the height. Yeah, that's so creepy, isn't it? Just a sign flapping right up there. So negative 0.01 times 6 squared plus 1.18 times 6 plus 2. I wonder how accurate the graph that you see is. Is it 8? 0.835? So is that leak verified? What did they say? 0.35.
72.
8.72? Approximately 8.72. No, I don't know if that's accurate, but would that just tip it? Would it block it? I don't know. But that's the number I'm looking. It would at least be able to touch it. Thank you. What are the units? Feet. How do you know?
Isn't the question.
It says in the question, the height in feet. And thank you for reminding us of our units there. Luke, do you agree with this 8.72? Raquel, you're good with it? Okay, thank you. Okay, if the ball is not blocked by a defensive player, how far down the field will it go before hitting the ground? Well, we know the answer is going to be more than 118, but shall we go over how to get that with your calculator? Okay, what we're going to do is we're going to set the function equal to 0. Okay, then on the calculadora, what's that? Exactly, y is 0.
It's like, back is equal to 0, or we're saying, because when f of x, are you saying f of x is equal to 0 is different from f of 0?
It is saying, yes, it is. So thank you. When we talk about something hitting the ground, by definition, that means that the height that it's reached is 0. Yes, if something hits the ground, it's no longer in the air. The height is 0. So if that whole thing represents the height, just set it equal to 0. Yes, exactly. Does it make sense? We're going to get 2 numbers? We're not. We're going to use a calculator for this one. Right, this would be a mess to factor. I think we all agree. Yeah. So let's do this together, shall we? Let me move this so I could see down here. Okay, video. Yeah, so this is gonna be a little bit of calculator work here. Let's just share. Hey, there we go. Okay. I know it's exciting. Okay, what we're gonna do is the left side of the equation is gonna be our y1. The right side is gonna be y2, which means, do you know how to get to the y? No. One, y2. Upper left button is called graph. I'm sorry, it's y equals, excuse me. Y equals, so I'm gonna clear whatever's here already. So I don't need that stuff. Clear. Okay, and then I'll hit the negative. Just make sure that when you hit the negative, where's that negative button?
Not the.
Under the
minus
three.
sign.
It's not the minus sign, it's under the 3. Negative 0.01. And did I tell you how to type in a variable? We don't need to do alpha. You can.
It's just the link. It's like.
It's this one next to the green button. That's the variable button. So x squared. I'll write into the.
Can we just press X squared or do you
Oh.
have to add?
The x squared button will square whatever already there. So you need an x.
Oh,
What's that? Do you want me to zoom in a little bit? Like that? Does that help? I'm just typing the left side of the equation first. And for y2, what am I going to type in? Type in 0. What does the line y equals 0 look like? It's a straight line. Well, all lines are straight. Y equals 0 is a line that is just, it crosses a y-axis. It's the same thing as the x-axis, y equals 0. Okay, so let's graph the picture of.
Zero.
What's that? Yeah, so please put zeros. And this is how we solve the equation on the calculator. This is one way. Anytime you have an equation, you put the left side as y1, you put the right side as y2. And now I'm going to hit this window. See this window button? And I don't want to see more than necessary. So my x min, that means how far am I going from the left to the right? So I'm going to go from 0 to, how far should I go for my x max? Because I know from my graph that we made for number 1, it's more than 59. So maybe in this case, 100 and
119.
maybe a little bit more. Let's give ourselves a little bit of room. 130, 125, more than the 118. I'll do one. Are we okay? This is where we're on window right now. If you don't see this, I may need to change your mode. Let me see what's going on here. And think about the 1 minute in MEMS. Okay, so 1 minute, 1 max, that means like how far down and how high up do we want to go? So 1 minute, let's make that.
Let's do the minimum or, you know.
Let's do it at 0. And then Y max, how high up should this go?
It should be like.
At least 36.81, so maybe 40? Are we good with this?
Are we have to do this?
Because what we're doing is we're setting the window so that we see exactly what we want to see. So we can now see it by hitting graph.
Whoa.
And it should look something like what we did already today. Right? Does
How much a semester?
120.
I got you.
Right.
Are you seeing it?
I think I was. Mine looks like this.
You didn't mess up. I think you just didn't do the.
Oh, no, you got it.
Correctly. Yeah, there's a problem with. Oh, yes.
There's.
I knew it was.
Someone else, I need to make sure that you see this. Oh, wow, I didn't go on.
Two.
Nice. Did you do that?
No. Next is. Make sure that.
Where's that? I messed up.
It's next.
Clear.
Mine.
Why? Why?
And put this back up.
I.
I'll be right there.
Oh, my God.
There we go. Wow, that's so.
Max. Sure. Well, fine. Oh. There. That's one that you're using?
Yeah.
What's funny?
Also,
Oh.
yeah, so I'm here, I have.
I don't know why he's on. Who's that?
Wait, why is he on it?
No, you haven't changed your X on. Did you change those to match here?
Oh, wait, we
Just
said-
use loaded.
Yeah.
Oh,
Right, so you should be typing these things in. Are. Did it work out? And you're seeing the full parabola?
Yep,
Can I help anybody with that?
I got it.
You got it. Okay, I do want to adjust one thing on the graph. Do you notice what's going on over here with, it looks like a cactus?
Yeah.
Do you know what's going on there? What's that? Yeah, those are little lines. What do they represent? 1, 2, 3, 4, 5, 6, 7, 8, 9. By counting up to 130. So let's just make it a little bit more sensical. Back to the window. Right now, this third option on mine, what do you think that SCL?
How much it counts by?
What does it stand for? Scale. It's a scale. So how many accounts? Right now it's counting by 1. So let's, instead of counting by 1, let's count by, I think 10 is a really good option. 11 would be a poor option, in my opinion, but you could do it if you wanted to. And you can see just a little bit nicer there on that X value. And we could see that. We could actually count, so there's about
Mine's
1, 2,
starting
3, 4, 5, 6, right? It's about 60, a little bit less than 60. Yeah.
Mine is like not that.
yeah, I got the same thing, just not one.
Oh, we haven't. That's a Y scale. Well, the scale on the Y axis from 1 to 5 is really.
I cannot.
Okay.
Otherwise,
Okay, so remember the whole point of graphing this is so that we could find out when the parabola is equal to 0, yes? So we're going to have to use a different function. Does everyone have both of these here?
I have all.
Okay.
I've.
no, I just cleared it.
Yeah,
There we go.
yeah, you are. That's perfect. And then when you graph it, oh, dimension, I know what's going on. See those things on top?
Yeah.
Got it on the top.
That's perfect.
You know, There you go.
It was I think, sure. Interesting.
Okay. So what we're going to do is we're going to find the point of, remember when you had two lines? You find the solution for when they intersected. We're going to find where the parabola intersects y equals 0. And do you see y equals 0 is on the graph? It's red. So what we're going to do is see that calc up here above trace? How do you access that second calc? And we're going to use which of these? Intersect, because we're looking at point of intersection. Now it needs to know which curves are intersecting, and because there could be up to 9 curves. Since there's only 2, I'm gonna go ahead enter for that y1, and it goes with the y2 automatically. So I hit enter again. It's gonna ask me to guess because, like Ben mentioned, there are 2 different places. So for my guess, I'm gonna move the cursor until I'm near the one that I want. And then I hit enter. Make sure that your neighbor did the same thing I did. It's got to be exactly the same. You did it? Yay. Yeah, and again, make sure that your neighbor has that 119.6715. And if you're having a hard time, maybe just ask Louise. There's yeah. You're there like this.
Something happened to mine.
Uh-oh.
How can you get back to like when it started, like started zoomed in?
Oh, this is them.
I
Uh-oh.
think I messed up really bad.
Man. Okay, I'm gonna have to send it to Dave's office. I understand. Yeah, it's just your window. I don't think you should zoom. I'll put my
Oh yeah, 'cause now I'm at like -60 grams.
yeah.
That's so weird.
So that 119 point blah blah blah, is that a surprise to you?
No,
No, we knew it was gonna be a little bit
under 118.
over 118. So it's not a surprise. Any questions? Okay, let's do some more, shall we? What? No, let's take a few minutes. Let's take until 12:32. To zone out, stretch if you need to. Mhm.
Sure is.
So, background.
That's really fun. I'm gonna send that.
Okay, let's get started, or let's continue. Happy birthday. Oh, before I move on, I meant to make sure for negative b over 2a, what function is helpful in the calculator? For negative b over 2a? Did I tell you how to type in a fraction?
No,
Uh,
no.
To type in a fraction,
and then the one with the.
alpha variable. Oh, quit, second quit,
Oh,
second mode. Did y'all see that for the fraction? Yeah. So Gideon, I think this is important because that mistake you made is a very common error. So just to make sure what's on top is on top, what's on bottom is on bottom. The fraction function alpha x. So you know exactly what's on top, exactly what's on the bottom. Okay, moving on. Did it work for you? Some calculators don't have that function. And if you don't, then I think it's alpha, alpha y. Alpha, and then that y equals button on the top left. Yeah, top left. Yeah, that's that one. Yeah, this side. That's the top right. So y equals. So yeah. So number one in that little mini list gives us a fraction. Did that work for you? Then one. A little complicated for that one, but yeah. Okay. Yeah, the other one's definitely nicer. It's just alpha x. Okay, let's go through some more of these. Now that we've done that one in depth, we're going to go through a little bit faster. You have 100 yards of fencing to enclose a rectangular region. Find the dimensions of the rectangle that minimize the enclosed area. Okay, guys, have fun. First step for this one is to draw a diagram. It's a rectangular field, so we draw a rectangle. Thank you. Thank you. Okay, do we know the width and the height? We know that the whole thing is 100. So since this is algebra, we don't know what these are. I'm going to mark this one as x. And the other one, well, let me focus on this. Let's see if we can get an actual number. What's this length? If the whole thing is 100, does it make sense that that length is 50? So I hope it makes sense that this would be 50 minus x. If the whole thing is 50. Right, if this would have been 10, then this would have been 40. If this would have been 1, this would be 49. So 50 minus x. You have 100 yards of fencing for a rectangular region. Find the dimensions of the rectangle that maximize the enclosed area. In this case, I'm going to say that a of x is equal to. Good question. It could be f of x, but in this case, a specifically represents the area as a function of x. So this is just using the same notation, but hopefully specific to what we're dealing with here. And the base is 50 minus x. The height is x. So a of x is equal to, multiplying this out, I do want it in standard form, so I hope you don't mind if I do negative x squared plus 50x. Which is what kind of a function? It's a quadratic function, so the graph is 8 for now. I'll do that maybe. It's about to go crazy if I just take that thing. Sorry for the distraction. So if I were to graph it, it would look something like, now the y-intercept, you notice, is 0. So it's going to do something like this. So I just have to find that maximum. How do I do it? Negative b over 2a. And this is our x-axis, so find the dimensions. So x equals negative 50 over 2 times negative 1, which is 25. So if this is 25, that means the other one is 50 minus 25 is 25. Dimensions are 25 by 25 feet, I believe. Oh, yards, excuse me. It's a square. Any questions? Is it a surprise that the maximum area is a square? It's pretty intuitive for a lot of people. Okay, a ball is thrown upward and outward from a height of 6 feet. The height of the ball, f of x, in feet, can be modeled by this function, where x is the ball's horizontal distance in feet from where it was thrown. Graph the function and models the ball's parabolic. Okay, let's graph it. Back to the calculator. It died. Oh no. There you go. And I want a good window for this, so I want you to play with it a little bit. So you see just what you need of the window to get a good look at the graph. I was using the last window. Is this a pretty good graph? That's it's a terrible window. So I want you to change the dimensions of the window so you can see like a nice arc. Yes, make it so you can see the window nice and we'll discuss it. What would be good. Check with your neighbor, see what they're doing. Okay, for my x, remember we're counting by fives here, aren't we?
I choose the 0.
So what are you doing for x? 0 to what? So 20? Are we good with that? For x's, yeah, x max 20? I don't know. It was just yeah, I think this one we're counting by fives. Yeah.
That'd be like 50.
So upwards of 60.
Was it counting? No, we were counting by tens here, weren't we? We were counting by 10. So maybe we don't 20? Do we need to go all the way to 20? Maybe 0 to maybe 10. I think 5, I'd be afraid of missing part of it. Let's do 0 to 10 for the x's. Let's see what that looks like now. Okay. Okay. I think we could do better.
So,
For the x's? X max? Okay, yeah, I'd like that. 7. Okay. Is that pretty good? It's still kind of terrible, don't you
5.
think? What's 5? X max for 5? Maybe. With that being 7, I'm pretty comfortable with the 7. What I'm not comfortable with is 615. Yeah, let's change that scale. I'll make it a scale of 1 so we can see. So it does look like I have to go up to, what's that? So 5.5? Oh, for the scale? I think 1 is enough. It's fine. What are you changing the y's to? 10? So, yeah, minimum 0, max 10. I just want to, we have a big screen here.
It's good.
Oh, that is nice.
Yeah.
That is nice. I hope that's comfortable, like just how we're changing that width or height, so we can get a really good look at the parabola. I'm comfortable with this. Okay. Is it a surprise that it has a y-intercept of 1, 2, 3, 4, 5, 6? Is it 6 or I don't remember what my scale is. Yeah, it's 6. Is that a surprise? I don't think so because yeah, it's already on the graph and on the function itself, right? That +6. So we graph the function that models the ball's parabolic path. Got it. Maximum height. I trust you to do that. How far does the ball travel? That means you're going to be setting it equal to 0. I don't want to do the exact same thing with you, but if you feel like you need to go over that, go ahead and do that. If you want to talk about it one-on-one, I have some time to help you. But let's take some time to, yeah, we have 15 minutes to crack the assignment if you haven't already.